Hi, I'm Sherry McCleary, the Executive Director at the Penn State Digital Foundry in New Kensington, and I'd like to welcome you back to part 4 of our 6-part series, Exploring Smart Manufacturing for Business Success. Today, we're joined by Vince Petrelli, our Senior Manager of Projects and Technologies, and Vince will be bringing us a look at supervisory controls, using SCADA and HMI systems to give you a real-time look at your shop floor data. Thanks for joining us, and come back with us next week when we will cover manufacturing operation management.
Hello, my name is Vince Petrelli. I am the Senior Manager of Projects and Technology at the Penn State Digital Foundry in New Kensington. For this presentation, we will explore several topics on supervisory controls. We will look at how people interact with machines, define a human-machine interface, or HMI, and explore what design considerations are important. We will introduce supervisory control and data acquisitions, or SCADA, learn the architecture of SCADA, and show how a SCADA system works. We will understand the advantages of SCADA and how they are used in industry. And finally, we will look at the anatomy of a typical SCADA system. So let's get started. The plant floor is seen differently in the automation world. We apply the definition of the ISA 95 automation pyramid to delineate software and hardware present in manufacturing. Level 0 is the production floor, or sensors. This layer is made up of a wide variety of sensor devices and technologies, including measuring instruments such as flow meters, level switches, proximity switches, etc., and actuators such as valves, pumps, and other instruments that keep variables such as flow, heat, and pressure within allowable parameters. Level 1 is the control or PLC layer, where PLC stands for Programmable Logic Controller. This is the level that is closest to your factory floor and where machine control resides. Level 2 is where you will find supervisor control and data acquisition systems, or SCADA, and human interfaces, or HMI. In this layer, process data is monitored through user interfaces and stored in databases. SCADA is typically used to control multiple machines and complex processes, including processes that involve multiple sites. Layer 3 is a planning level, which contains manufacturing execution systems, which monitors your entire manufacturing process from raw materials to finished goods. And finally, layer 4 is the top layer, built around your company's enterprise resource planning, or ERP. This gives company decision makers information from every level of the automation pyramid. Whereas MES monitors and controls a single plant, ERP provides monitoring, reporting, and control across the entire corporation. Human-machine interface, or operator interface, is a graphical user interface for the operators, which displays process information such as process variable status, logs, results to the database, generates alarm signals, and may provide simple trending. Just like you would interact with your air conditioning system to check and control the temperature in your house, a plant floor operator might use an HMI to check and control the temperature of an industrial water tank, or to see if a certain pump in the facility is currently running. HMIs come in a variety of forms, from built-in screens on machines to computer monitors to tablets, but regardless of their format or which term used to refer to them, their purpose is to provide insight into mechanical performance and progress. The HMI shows vital information about machine conditions using graphical and textual views. In some machines control applications, multiple machine-to-machine protocols may be used, and often HMIs may be used for protocol conversion. This functionality can be used to exchange data such as status and set points among different controllers and other smart devices. Some HMIs can also send data to the cloud or enable remote access functionality through the internet, giving proper username and password authentication. A highly reliable HMI system delivers safe, cost-effective, consistent, and intuitive performance, relying on the application of engineering best practices throughout the design, panel layout, production, testing, and quality assurance processes. Just as critical, in-depth knowledge of and compliance with all relevant ergonomic, safety, and industrial standards must inform each step of the design and manufacturing cycle. Clear definitions of the functional requirements, your operator's level of expertise, and any communication or interactions with other systems provide a starting point in the knowledge-intensive design process. Operator and functional requirements provide the tools necessary for effective operator control of the equipment. Feedback to the operator is critical to operator effectiveness and efficiency. In some cases, feedback provides confirmation of an action, while in others, it adds to the functionality. For HMI systems design, safety considerations are a critical part of the overall system. Environmental considerations include the application environment, which encompasses both physical location and industry environment, which determines HMI system durability requirements. The HMI system should be rugged enough to withstand the elements and heavy use, but also should last for the entire duration of the equipment lifecycle. The key to a successful HMI system implementation requires well-grounded definition and understanding of the operator's requirements. For an expert user where more sophisticated controls is desirable, there may be multiple layers or levels for interfacing with equipment. However, once you've established how an HMI will look, feel, and operate, consider how the HMI will connect to and communicate with the core equipment or system under control. Typically, communication can be achieved through several approaches: hardwire connections, serial bus connection, or wireless connections. Supervisor Control Data Acquisition Systems, or SCADA, are used for controlling, monitoring, and analyzing industrial devices and processes. The system consists of both software and hardware components and enables remote and on-site gathering of data from the industrial equipment. SCADA systems are designed to collect field information, transfer it to a central computer system, and display the information to the operator graphically or textually, therefore allowing the operator to monitor and control an entire system from a central location, real time. Hardware and software in a SCADA system work together to control and monitor equipment in an industrial process. SCADAs increase workflow efficiency by capturing real-time data of the process and allowing changes to the control and set points from a remote location. There are 4 components considered part of the basic architecture. Field controllers, or remote terminal units, or RTUs, are compact microprocessor-based control units installed at several different physical locations of the system. These devices share many similarities with PLCs, but have some distinct characteristics. RTUs serve to monitor and control one or more field devices at a time. These field devices can be sensors, valve actuators, and many others, both analog and digital. Field devices or inputs. These include all field instruments monitored and controlled by the RTUs. The type of instruments, as well as the quantity needed in a SCADA system, is determined by the type and size of the application. SCADA communication networks, a well-designed network, is essential for the efficient and reliable flow of information in a SCADA system. Some of the most common connectivity platforms are Ethernet, optical fiber, and Wi-Fi. Finally, HMI software. The HMI interface software provides an intuitive graphic user interface and input-output controls to help monitor and operate sophisticated industrial equipment. HMI software can be installed on HMI hardware or regular PCs, mobile devices, and wearables. Okay, the difference between HMI and SCADA is, well, HMI is a component of SCADA, but SCADA is not a component of an HMI. SCADA is a remote monitoring system, and HMI is local to the plant or process. HMI is a one-to-one relationship between the operator and the machine, but a SCADA can handle a lot of machines and processes. It is possible to use HMI without SCADA, as HMI provides a graphical user interface to control and monitor machines, while SCADA, on the other hand, is designed to provide more comprehensive monitoring solutions over larger networks of connected machines. HMI usually does not store data, but SCADA has a historical server that can contain its database. An HMI, for example, will be placed on the control panel near a part of the machine, where a SCADA would be set up in the control room far away from the machine itself. The SCADA software receives data collected from machinery, equipment, and devices and processes. This is how it works. The data is then displayed on screens and dashboards, often on animated graphs, diagrams, and images, so the operators know in real time what is happening on the floor or in the field. With the use of alarm screens, the operator can analyze this data to determine whether operations are running optimally or whether they need adjustment or urgent intervention. For example, operators can use the SCADA system to change rates and settings, recalibrate equipment, or shut down a process altogether if necessary. SCADA systems are often accessible from industrial HMIs, tablets, laptop computers, and cell phones. What are the advantages of SCADA? Well, SCADA systems offer numerous benefits to businesses in various industries. SCADA's remote monitoring and control capability enables efficient, centralized, and process control. With real-time data collection analysis, it is possible to make informed decisions, resulting in increased efficiency and cost savings. SCADA can also improve safety by monitoring critical process parameters and equipment in real time. As a result of SCADA's ability to optimize processes and decrease downtime, quality and productivity are also enhanced. SCADA systems are adaptable to processes or equipment requirements changes and can be tailored to meet organizational needs. So where are SCADA systems used? SCADA systems provide a critical role in providing several industrial applications and are used to control and monitor physical processes. Some of the industries that use SCADA in their daily operations include water and wastewater systems, electric generation, financial systems, and more. Both large and small systems can be built using the SCADA concept. These systems can range from just tens of thousands of control loops, depending upon the application, and vary to include industrial processes, including manufacturing, process control, power generation, fabrication, and refining. Infrastructure processes may be public or private and include water treatment and distribution, wastewater collection and treatment, oil and gas pipelines. Facility processes include buildings, airports, ships, and space stations. They monitor, control heating, ventilation, and air conditioning systems, HVAC, building access, and energy consumption. SCADA systems may have security vulnerabilities, however, so the system should be evaluated to identify risks and solutions implemented to mitigate those risks. So, taking apart what it looks like inside the software SCADA system, typical software pages or displays include a graphical representation of the process and may include real-time and summary process values and control elements like push buttons, switches, dials, and text boxes. Pages may also contain a variety of graphical objects. Pages can contain components that may be static, or they can also change depending upon what the user clicks or selects. Tag assets and user types refer to any real-time variable or its associated historical data. Tags are the process variables for your application. Use tags and their properties to set up the data model for your processes. A report page provides predefined report types designed to analyze the performance of the equipment in your facility. SCADA systems may have built-in internal databases or may connect to an external database. A data historian is a type of time series database designed to effectively collect and store process data from a SCADA or automation system. For devices and interfaces, the SCADA system will connect to the process through a PLC with a variety of standard open protocols such as OPC-UA or MQTT. Alarms are unexpected and might need corrective action. Events are expected and noteworthy and are reported to determine historical sequencing to the process. SCADA systems may also use scripting, which is an advanced feature that requires high-level programming languages such as Python. These will enhance the capabilities of the system. Security involves firewalls to separate process control networks from the administrative networks. Now, once your project is built, you will need to test them before running in production. So you need to look for options to trace functionality and property watch windows to track your code when it's running. Key takeaways. To implement supervisor controls, determine how the ISA 95 automation pyramid fits your facility. HMI is a one-to-one relationship between the operator and the machine, so it may be a local system. A SCADA can handle a lot of machines and processes and may be remote. SCADA's remote monitoring and control capability enables efficient centralized process control. It's possible to use HMI.SCADA, and as HMI provides a graphical interface to control and monitor machines, while SCADA is designed to provide more comprehensive monitoring solution over larger networks of connected machines. SCADA systems offer numerous benefits to businesses in various industries. For smart manufacturing with real-time data collection analysis, it is possible to make informed decisions resulting in increased efficiency and cost savings. SCADA may also improve safety by monitoring critical process parameters and equipment in real time and alarming in real time. As a result of SCADA's ability to optimize processes and decrease downtime, quality and productivity are enhanced. SCADA systems are adaptable to processes or as equipment requirements changes and can be tailored to meet organizational needs. So that brings us to the end of the presentation on supervisory controls.
So while today was just a very brief glimpse into how we define smart manufacturing and why you should care because it can have real value to your business, we want to close with letting you know that we can be of help at the Digital Foundry. At the Digital Foundry, our mission is to focus on delivering access to digital technologies through education and training, through awareness events, and through technical assistance or de-risking with manufacturers in our region. So we can help you in taking those steps to become smarter in your operations, to implement smart manufacturing, to make better decisions. And some of the specific services that we can provide to help you get there include starting with assessing your current state, coming in and helping you to understand what are the biggest challenges and where should you start small to continue to access success and wins. We can help you with mapping your strategy and your plan through strategic road mapping processes that have been proven with other participants in industry. And we can help you with doing prototyping and de-risking of technology in our shop, where you can see how it works, understand it, understand the business value before you go out and make investments in your shop. We also offer unique workforce training to help you to upskill your staff at levels from entry level on the plant floor all the way up to your engineering staff. And we can provide coaching for your team to make sure that you're setting yourself up for success. We're here to be of service to the workforce of the future and the current, and we also are here to be an asset to local manufacturers. So take advantage of what we have to offer and some of the support that we can give you in taking this journey. Thank you for being part of our Smart Manufacturing series, and we look forward to talking to you again. Please connect with us through our website and social media.